So today we will be starting with another topic called energy stored in the capacitor. Now suppose we have a capacitor and this capacitor is connected to a battery. This battery, due to the connection, there is a potential difference between two plates of the capacitor. And suppose that this capacitor has a capacitance C, and after connecting to the battery, it acquires a charge Q. This particular plates have positive charge Q and the other one have negative charge Q. So let's see what happens during the process of charging the capacitor. During the charging, what happens is this particular plates, they would start acquire certain charge, and this is certainly dependent on the potential as well as the capacitance of the capacitor. Suppose while the battery is charging the capacitor acquires a charge small dq, and this dq amount of charge is bit by bit getting transferred or getting stored by the capacitor C. Now when the amount of charge Q is getting added to this particular plate, battery has to work against the attraction force between the positive charge that is entering to this plate and this positive charge, and already there is this positive plate. They will have a repulsion force, but still this force has to be added. So against the repulsion force, the battery has to work. The same way, from the negative plate, positive charges have to take away, and this battery have to do work to pull this positive charge out of this negative charged plate, and to pull this positive charge out, it has to work against a attractive force, because we know that positive charge and negative plate will have an attractive force. But from this attractive force, you have to pull the positive charge out, and for that the battery has to do the work. Just suppose that this work is being done by the battery. Suppose the battery has to do the work dW, and that's how dQ amount of charge is getting stored in the capacitor, right? So as we know that work done is potential into the small amount of charge transferred. Now when we have to calculate the potential, this potential is nothing but Q by C, amount of charge that has been given and the capacitance of the capacitor. So as the battery was connected, we know there was a potential difference that has been arised, which is V, and this potential difference is Q by C, as we have assumed before. And now we know that if we think of a small amount of charge dQ being transferred or being stored to the capacitor, it means that to store, battery has to do certain work. This work is due to the repulsion, the work against the repulsion force at the positive plate, and work against the attractive force at the negative side of plate. And this work is what is getting stored as the potential energy. So if we have to calculate the energy that is stored in the capacitor, first thing what we are doing is we are calculating the work done by the battery, which is getting stored in the capacitor. So this work done that we have calculated is the potential difference across the plate into the dq amount of charge, which is in a bit by bit getting transferred or getting stored to the capacitor. So now when we just substitute it, V is Q by C into dq. So this is the small amount of work that has been done to store a little amount dq amount of charge. Now same way, the battery has to charge the capacitor. The battery has to continuously do the work to store Q amount of charge inside the plate, and to do that, let's suppose the battery have to do certain work W, and this W work done has to be done from a zero storage when the capacitor wasn't charged at all to a storage where the capacitor has a charge Q. So this has to raise from zero storage to the store of a charge Q. So if we integrate from this to this over dW, we would get what is the total work done by the battery to store a charge Q amount inside the capacitor. So if we do the integration, first we would substitute for dW, which is Q by C dQ. Now as C is the constant, comes out here, it becomes Q dQ, raising from 0 to Q, which is 1 by C. Integration of Q dQ is Q square by 2. It has to be from 0 to Q. First, when we substitute Q, it becomes 1 by C Q square, or I can write it as 1 by 2C into Q square. For if you substitute 0, first we substitute upper limit minus lower limit. If you substitute 0 for the Q, answer would be 0. So we are not taking that part. So definitely it is Q square by 2C. So what we see, the work done is equal to Q square by 2C. Now in another way, we can write, as we know, Q equal to C into V. So we can substitute this as C square V square by 2C, or equal to half C into V square, right? So once we substitute Q equal to CV into this expression, we get work done, total work done is half into C into V square. Or again, if you substitute for, let's suppose if you substitute for V, which is Q square by C, we will get the same thing. So if you substitute for C is V by Q, in the same expression that we have got half C V square, if you substitute for C, you will get half C is equal to Q by V into V square. So you will get half Q into V. So this is the different form of the same equation which we have now got, that is W equal to half CV square, which is the same thing, half Q into V, or half Q square by C. So this is the total work done by the battery, and this work is being stored as the potential energy. So this work, again you can write U equal to W, which is the same expression. So you can say the energy stored or potential energy stored by the capacitor while charging by the battery, and while charging battery does certain work, and this work we have calculated as half CV square, and this work is stored as the potential energy by the capacitor.